In this problem, I am modeling a coffee company that has 3 different blends of coffee that they sell. To produce these 3 different blends of coffee, they are using 4 types of coffee beans. For each blend they produce, they have a demand that's available. They have a certain production capacity. Also, for each type of coffee bean, they have certain availabilities that we're given. And our goal is to find the best way of producing the blends while maximizing the profit. So as usual, I have a modular worksheet, decisions, constraints, objective. I have yellow for the decision variables, blue for all the inputs, and orange for my objective function. Let's say I decide to make 10 pounds of the hotel blend, 20 pounds of the restaurant blend, and 30 pounds of the market blend. In this particular workbook, I also would like to highlight one more thing. I have given range names to different cells, which will make my workbook much more readable. And you will see how that plays out as I'm trying to type in the constraints and type in the formulas, also as I'm trying to create my model using the Solver platform. So the total production is the sum of these 3 values, which I name production level. Now I need to figure out how much of each bean is used. To figure that out, I need to look at how many pounds of each blend is produced and what percentage of that blend is coming from, let's say, the Robusta beans. So here I have a sum product which looks at my production level and then my percentage of Robusta use. And when I hit enter, I will see that with this particular production schedule, I'm using 12 pounds of the Robusta beans. And I can copy paste this and I don't need to worry about the absolute referencing because I already have a range name. This shows me how many pounds of each type of bean I've used. The next thing I need to figure out is the total profit. In the problem, I'm given the price of each blend, but I don't know the cost of each blend. In order to find the cost of each blend, what I can do is I can look at 1 pound of a blend and figure out what type of beans, what percentage of what type of beans that pound uses by using the cost per pound values here. So if you look at my formula in B20 here, it says, well, look at these percentages, look at the cost per pound, that gives you your blend cost per pound. And then in the profit portion, I say, well, look at the price minus the cost, that gives you the profit. So let's look at the total profit. It's going to be the sum product of the production level and the profit. So now that I set up my worksheet, the next step is to set up the model. So I go to my Solver platform ribbon, I choose model, go to optimization. Let's go this way a little bit, yes. Optimization, so my objective is going to be total profit, push enter. As you can see, I had named that cell, so instead of giving me E22, it's giving me total profit. My variables are these. This is what I'm trying to decide on. Production level is my decision. My constraints is, well, let's enter them one by one. First of all, I need to make sure that total production is less than or equal to the capacity. As you can see, I can read it over here now. The next constraint is going to be production level should be at least as much as the demand. The next one is going to be, well, the used beans should not be more than the available beans. And I think that covers it. Note that we have 3 sets of constraints. The first 2 came under normal constraints. The last one is under bound. So if you have any constraint that gives you a direct bound on the decision variables, then that's considered a bound constraint. And here I'm saying production levels should be at least as much as demand. Now I'm ready to solve the problem. I'm going to go ahead and hit, and it gives me the solution. Now let's see if the solution makes sense. I'm making as much of the restaurant blend as possible, which makes sense because that's the most profitable one. And the next one I'm making is the market one, which is the next profitable one, and the least of the hotel blend. Good. And when I look at the beans, I am using the Liberica bean to its limit. It's also the cheapest coffee bean, which again makes sense. I'm trying to come up with a solution that uses the most of the cheapest bean and produces the most of the more profitable blend. And again, I'd like to highlight here that when you look at the model description in the dialog box, it's now very easy to read. I'm trying to maximize total profit, deciding on the production level by using 3 constraints, and the constraints are very well defined as well. So one good use of range names is an optimization where you're trying to describe your model to an external user. They'll be able to understand it much better if you have range names like this. In this particular example, just like problem 3, I have given you also another version of formulating this problem. You may also want to look at this and see if it makes sense. Again, between the 2 versions, I prefer the first version, but if you like this one, feel free to utilize that one as well. That concludes our discussion of problem 10 in chapter 9.